Alrighty, so today we're going to be having a look at the final step of our seasonal sort of journey, which is going to be looking at how do we deseasonalize data. Now, the idea of deseasonalizing data is trying to smooth the data, similar to the 3-point moving mean or the 3-point moving median. And what it's really useful for is if you've got really strong seasonal data, by deseasonalizing it, it will smooth out all of those peaks and troughs to make predicting with it easier. So how do we deseasonalize? Well, to deseasonalize, you simply take the value for a particular year or a particular season, and you divide it by the appropriate seasonal index. Usually we use the best seasonal index, meaning if we've got access to multiple years of data, we'll use the averaged seasonal index, not the given seasonal index. So you can see this is the same data from last time, but the seasonal indexes, averaged seasonal indexes, have been written at the bottom for us. So usually we use the average seasonal index. If you use the regular seasonal index, it's not going to do what we want it to do. Alrighty. So what this one wants us to do is it wants us to deseasonalize the entire data set, and then we're going to plot both of them next to each other. So I'm going to do a big table off to the right here. It's going to have the same columns. It's just going to be a little bit bigger so I can do some calculations. Alrighty, so let's deal with the first one. December to February of 2016. 32 is the original value, and we're going to divide it by the appropriate seasonal index, which is going to be 0.8. And this is actually going to increase it a little bit. It might seem a little bit strange, but that's what it's going to do. And we're going to also repeat that for that entire December to February column. So we're also going to do the same thing for 48. And we're also going to do that for 45. Alright, I'm going to be rounding to one decimal place throughout, but you can see that those are the deseasonalized values for the first season, for summer. Now let's repeat that for March to May. So for March to May, for 2016, we've got 60, and its seasonal index is 1.26. So let's go through and do that now. Then we can do it for 70. And again for 65. To the calculator. And we can repeat it for the other two seasons as well. So the June to August ones are going to be divided by 1.07, and the September to November ones are going to be divided by 0.87. So it's really important to be careful as we go through this whole process. We've just done 12 calculations, so there's often a chance that mistakes can happen, so please just be mindful as you're going through it that you go through it very, very carefully. So the next thing they ask us to do is to do a graph of it. So we're going to be breaking up into the years, and we're also going to be breaking it up into the 4 seasons for each year. So let's actually start with the x-axis. The y-axis is going to be pretty easy to do. The smallest value we've got out of all of our values is 32. I don't see any numbers that are smaller than 32. Neither in this data set nor this data set. And then the largest value, I think, is 70. I don't think we have any values bigger than 70. But our x-axis, on the other hand, is going to be a little bit more interesting. So for our x-axis, let's start with 2016. So for 2016, we need 4 dashes, representing the 4 different seasons. Then we're going to do the same thing for 2017. And similarly for 2018. And this is going to be the season. Now, just for simplicity, we might put, say, D to F for that one. The next one will be M to M. Then we've got J to A. And then we've got September to November. And then we can just repeat those. And there we go. There's our x-axis set up. Now we can do our y-axis. As we said, smallest number is 32, so we can start with a nice 30, and our biggest number was 70. So we're going to go up in terms probably, so 30, 40, 50, well, I could probably do a little bit bigger than that. 30, 40, 50, 60, and 70. And this is the sales. Alrighty. And we can put in our little half lines as well. And now it's just going to be a matter of drawing our bivariate data, which just means that it is going to be a dot to dot. So 32, 60, 50, 32, 60, 50, 38. So that's my first year, 2016. Let's do 2017. 48, 70. And then we've got 60, 52. Alrighty, and once you've done all of that, then you can start doing the dot to dot. Alrighty, so there's my raw original data. So this is the sales. And now what we're going to do is we're going to put in our smooth data as well. Alrighty, so let's do the 2016 smooth data. So we get 40, 47, 46. $46.7, $43.7. And you can see already, just based on these first couple of points, that we've smoothed everything, we've pushed everything towards the middle. So that means the valleys have become a little bit higher and the peaks have become a little bit lower. So it's a really, really useful skill, this deseasonalising. Anyway, I'll finish up doing the plot. And so you can now sort of see in our final graph that it really has smoothed out the data quite significantly. And that's really the power of using this sort of technique, is that you can really smooth out the data. The other advantage is that then you can start to see a little bit more of a trend. You can sort of see in it that overall it is an increasing trend. And if we wanted to find the trend line or the line of best fit, well, we're going to probably get a better R squared value or R value because the data is more linear now that it has been smoothed. All of those peaks and valleys make the data a little bit less linear as well. So it might even be easier to predict with. Alrighty, so that is deseasonalizing. I might just touch up my graph and then I'll see you in the next one. Goodbye.